Good morning, everybody. We're going to be doing a little bit of Unit 8, Lesson 5 today. We are not doing the whole thing. We are not getting into the super complex completing the square work. So we just wanted to go into Unit 8, Lesson 5. Before we do that, why don't we do a quick do now of completing the square, just so we feel comfortable with what we did 2 days ago now it's been. Let me write up an equation, and I'd like for you guys to give this a try on your own. And my question is going to be, find the vertex using completing the square. Take a moment to pause this, and let's come back to it and confirm that you are good with it. Okay. Okay, so hopefully you've had a chance to pause it, and I'm going to make this smaller so I can have room. Okay, so remember, the first step is going to be take the b term and divide by 2. So we're left with -4. I always box that. That's my clue for later on, so I don't have to think too much. I'm now going to take my b over 2 and square it, and I get 16. That's my c term. So now I'm going to come back and I'm going to rewrite my formula. Y equals x squared minus 8x. I'm now going to input the new c, 16, subtract the new c, minus 16, plus 5. Okay, so now when I take my perfect square trinomial, I'm left with y equals x, go up to your clue, minus 4 squared. That'll be a perfect square trinomial turned into a binomial squared. And then I'm going to do my final math. So what is the vertex in this case? So by the way, this is called vertex form that we've written it in. So if a question asks you to write the equation in vertex form, you would leave it like this. But if it asks for you to find the vertex using completing the square, or find the vertex by finding the vertex form, you would do this final step, which is, remember, the x value is going to be the same number, different sign. So in the case of this, it's going to be not -4, but +4, and it would be -11. Certainly, I could check this on my calculator to be on the safe side that is in fact correct, but this would be how you would do it. Okay. And I noticed that a lot of you on your homework did a fantastic job on the homework assignment. Really, really good. I was very, very proud and impressed, and you should be proud too, because this is not an easy topic. Awesome. So today we're not going to be doing the whole lesson 5. In fact, we're only going to be doing question 1 and question 2, and I'm going to do a few questions on my own. So the first question, what they want us to do is use our calculator, so make sure you have it, to sketch out what would happen on the graph if I did x squared, if I did 2x squared, and I did 4x squared. So why don't you go to your calculator right now? I'll go with you, and we will go to y equals, and we'll do all 3 of these. Let me just change this because I was doing something with my stats class and I need to get this organized. So now I'm on y equals, and certainly we know that x squared is what I call the baseline graph, and that's going to be, sorry, got to zoom 6. So let me sketch this. What is it going to? I know that x squared is going to be starting at 0, 0, obviously. And actually, you know what I'm going to do? I'm going to go and I'm going to look at the table so you feel comfortable with how it's going up, because it's going up to 15 on this graph. I don't need to go that high. At x equals 3 and x equals -3, it goes up to 9. And then from there, it shoots up to the moon at 16, etc. So if I'm going to be here, this is 4, this is 4, here's 0, 0, here's 1, 1, here's 2, 4, and here's 3, 9. Boop, boop. So it looks something like this. It's tough to do with your finger. It really is. Let me see if I can smooth that out a little bit. Oh, my goodness. Okay, so 2x squared, let's put that in the calculator now. I'm going to keep the x squared so you can see what's going to happen. And this is now going to be a red graph, 2x squared graph. And you can see that the graph got skinnier. Now, what happened is it's being stretched. Why is it being stretched? Because I'm after I do the x squared, which is what you're going to do first because that's PEMDAS, you then multiply it by 2. So all of our numbers are going to get stretched pretty quickly. For example, when x is 1, y is not going to be 1, it's going to be 2 because you multiply by 2. When x is 3, for instance, it's not going to be 9, it's going to be 18. So it really gets stretched really quickly. So let me actually use that color now, and I'm going to do, it's 0, 2, and 8. 0, it's still 0, so we'll go here, it's still 0, but now instead of having it 1, it's going to be at 2. So something like that. I mean, this isn't perfect because I'm doing this on my page here. And then instead of 4, it's going to be at 8. So maybe something like this. How's that look? And then certainly 3 is going to be somewhere up here, right? So it's going to look something like that. And it should be kind of like curving. I'm sorry. These don't look great. What do you think is going to happen with 4x squared? Hopefully you're knowing that it's going to stretch even more. So let's go to 4x squared. I'm going to keep it on here too. So now this is going to be, you know what I'll do? I'm going to put mine here. I'm going to have it green so you can see what it looks like. So I'm going to have 4x squared. Oh, that says 74. 4x squared. And I'm going to graph that. And sure enough, it even got skinnier. It's asking us to sketch it. We don't have to be precise. But what's happening here is now I have 0, 4, and 16. So it's going to be 0 again. Interesting. 4, boom, boom. And it goes all the way up to 16 when it's 2, like this. So it's going like this. Question B says, explain what's happening when we multiply x squared by a. The y value is increasing by that amount. So what I would write here is the y value is increasing by a times a, okay? So that's giving us a general idea about what's happening. If you noticed, the main thing is, that's also important, the vertex stayed the same. So for all 3 of them, they started at 0, 0, right? Okay. So let's go on to the second question. What they want us to do is they want to look at these different graphs and they want us to write the number of the equation besides each curve. Now, if we multiply by a number greater than 1, it gets skinnier. What do you think happens when we multiply by a number less than 1, which is a fraction? It's going to get wider. So it's going to help you with these. And if we have a negative in front, what do you think is going to happen? It's going to flip. So why don't you have an idea about where these different numbers are going to go, and then I will help you with that. Okay, so I always start with the negative ones first. And we have negative 2x and we have negative x squared. So we have negative x squared. So if it gets skinnier when I multiply by a number, I know that this is going to be, inside the skinny, is going to be number 3. And therefore, number 5 is going to be our negative x squared. So now let's go up to the top. So now we have x squared, we have 1/2 x squared, and we have 3x squared. So 3x squared is going to be the skinniest, so it's going to be 1. My widest is going to be 1/2 x squared, which is going to be 2, and therefore my middle number is going to be 4. I know it's counterintuitive. I've talked to you about this before. I would prefer to be half my size, maybe not half, but some other smaller size, but not in parabola land, because parabola land I would be wider. Okay, so I've added a few additional questions, so please just write them down somewhere on your page. And I want to go through these 3 questions with you, okay? So these are not in your book. I've just made them up. So if you noticed in question 1, when we did the problems, when we multiplied our x squared value by a number, 2, 4, 1/2, it didn't change the vertex. What I want you guys to know is that questions like A, B, you'll see, and C, you'll see, are super duper easy because all you need to do is look at the problem and say, oh, it's going to be the number in the parentheses and the number outside the parentheses. So for example, let's look at A. We have 2 parentheses x minus 1 squared plus 3. This 2 right here, We don't care about when we're talking about the vertex. Doesn't matter. Yes, we know it's going to get skinnier. It doesn't matter for our problem. So let's just focus on what's in the middle here. So if I'm asking for the vertex, remember the rule is same number, different sign, 1, same number, same sign, 3. And that's it. Can I just confirm that for you? Sure, I'll confirm it for you. Not a problem. So we're going to go here. I'll just put it right here. 2 parenthesis x minus 3, minus 1, sorry, squared plus 5 plus 3. Why am I saying all these numbers wrong? Delete. Oops. Delete. Why is it not letting me do this deleting? Delete. Okay, good. So let's just confirm. So I'm going to graph it. Oh, of course, I did something wrong, right? You guys are like, I know, I saw what you did wrong, Mrs. J. Oh, I said get rid of this thing. Delete. There we go. Graph. Okay. Okay, so don't worry about the other 2 graphs. I'm looking at the blue one right now, right? So the blue one I can see is at 1, 3, but let me just confirm it. Go to second table. And sure enough, my blue one, the only one doesn't have a partner. We have 5, 5, 11, 11, 21, 21. The 1, 3 is all by itself. That's how you can confirm it, okay? But if you notice, it took me to do A manually 5 seconds. To put it in the calculator takes a minute, not a big deal. Let's talk about B for a minute. Take a look at this one. I want to actually, so first of all, what's the vertex? Okay, so the vertex is going to be same number, different sign. So it's going to be, sorry, I don't know why I'm having problems today moving my arms the way I want them to, 2 comma negative 4. But what if I did this? What if I said this was me bouncing a rubber ball? This is the formula that I figured out because I have all this time now being home to figure out what the formula would be for me bouncing a rubber ball and the trajectory of that rubber ball going, down the street or whatever. So this would be, remember, when we're talking about a rubber ball, think about how the graph would look. The graph would look something like this, right? The rubber ball would go like this, right? So if I asked you what well, in this case, it's not the rubber ball, it's, this is a bad example because I'm trying to think of something that would be the rubber ball would be the flip-flopped. What if I put a negative in front of this just for kicks? So what would happen is if I said to you, how many seconds was the ball in the air at the vertex, and what was the vertex? This is a terrible example. I'm going to switch this one. Scratch what I just said. I'm going to do it for the next one, okay? I'm going to do it for the next one. I apologize because I want to use this next one. I'm sorry. Okay, so let's look at this one right here. Still not great, but we have a negative, so it makes it look like this graph a little bit. So this one, this graph, we're asking for the vertex. The vertex is going to be the same thing. Don't worry about this negative because that's really -1, right? The -1 in here is going to be not needed. I don't have to worry about it right now. So we're going to be left with x is the -1 and then the -5. So we're left with the vertex being 1 comma -5. Okay, so what am I talking about here? Let me just show you. So our homework is only going to be question 1, question 2, question 4A, and question 5A. I don't want you to get upset about question 4A. I don't know what to do, Mrs. J. I want to walk you through it real quick. They have a projectile. Someone shot something in the air, and here's the formula. They're giving us the formula right here, and they want to know what the maximum height is and at what time does it occur. Remember, the T time, when I drew a graph, you can see the graph over in the bottom right of question E, that we don't have to do question E, would be the time, which is the x values. So whatever you get for your x value, that's going to be the time it was in the air for the vertex. And then it wants to know how high it was. That's going to be your y value. So I'm going to stop right there. That's all our homework is. It's all we have to do for today. I'm going to do office hours today at 1 p.m. and I hope you guys can make it. Have a good day.